Alright, hey guys, this is 7.2. This is Law of Sines. So today we're going to start talking about triangles that are not right triangles and how you can solve for all the missing sides and all the missing angles of those. So back in Math 2, you started talking about like angle, side, side, all of that fun stuff. So we're going to bring that back. So there's kind of 4 different cases. So angle, angle, side, side, which you probably learned back in Math 2 was not allowed, but we're going to solve it today. 2 sides and included angle, so side, and then side, side. So we're going to focus today for law of sines on case 1 and case 2. You don't really need to memorize that so much, as you'll realize you won't be able to do it for case 3 and case 4. We'll have to use what's called law of cosines for those other 2. So you'll get stuck. So not something you necessarily need to memorize. The formula for it is pretty simple. Once you get going with it, it'll come pretty naturally. So it's sine of A over A. One important thing to note, I'm just going to draw a triangle out here. So angle A, angle B, and angle C. So they used alpha, beta, and gamma. This is gamma. If you want to use a capital C, that's fine. That's probably what I'll end up using. It's just the first 3 Greek letters of the alphabet. It's just kind of to differentiate these angles and these sides. So A, capital A, is always across from the side little a. Capital B is always, or beta, is across from little b. And then C, little c. Okay? So just know that these sides and angles have to be across from each other. So this is what they mean. So sine of A, so the sine of A divided by A equals sine of B over B, and there's those proportional relationships there. So we're just going to do some examples with this. These will be pretty straightforward, not a lot of application with this that you'll have to do on a test, but mainly just working with the triangles, okay? There is one thing called the ambiguous case. We'll get into it a little bit. That can be a little bit confusing, but we'll start off with some easier ones. Alright, so here's the first one. So solve the triangle. Remember, when I say solve the triangle, I'm looking for all missing angles and all missing sides. So the first thing I notice is I can easily find this angle right here because all angles add up to 180. So I'm going to say that gamma, or you can call it big C, I don't care, equals 100. So 180 minus 100 degrees, so that's 80 degrees. Okay? So that's pretty easy to find that missing angle, and I'm going to go ahead and label that. Okay? Alright, so next we're going to have to set up our fractions. So I noticed that these 2 I know, so they're going to have to be a proportion together. So what I'm going to go ahead and do is set them up. So sine of 40 over 4, they go together. And then it doesn't matter which one you do, but let's do the 60 first. Equals sine of 60 over b. Alright, so I'm going to solve for b. How I'm going to do that is just some cross multiplying. So I get 4 sine of 60 equals b times sine of 40. So then last step is divide this by sine of 40. So basically you just have to type that whole mess in your calculator. Okay, again, making sure that it's in degree mode, close your parentheses, all that fun stuff. So I'm going to give you a second, and I'm going to check mine just to make sure. Okay, so to 3 decimal places, you should get 5.389. Okay, then all we're going to do is we're going to repeat the same exact process, but we're going to do it with 80 degrees and C. So sine of 40 over 4 equals sine of 80 over C. Cross multiply, So 4 times sine of 80 equals c times sine of 40. Divide both sides by sine of 40, and c is going to equal this whole thing typed in your calculator. So c equals 6.128. And 5.389. Okay, and that's it. Alright, same thing for this one. So again, if I have two angles, I can really easily find my third angle. So I'm going to go ahead and do that first. So 180 minus 35 minus 15. So that's 180 minus 50, so that's 130 degrees. Okay, so then again, I'm going to set up the very same process here. So this time I have this first proportion here. So sine of 130 over 5 equals sine of 15 over b. Remember, it's the ones that are across from each other. Alright, I'm going to cross multiply. 5 sine of 15 equals b times sine of 130, and divide both sides by sine of 130, and you should get b equals 1.689. Alright, I'm going to set up the last one, but it's the same process. So sine of 130 over 5 equals sine of 35 over a, and then your answer for a should be 3.744. Again, notice, so 130 degrees is across from the biggest side, which is 5. 35 degrees is across from 3.744, which is the second highest number. And then 15 degrees was across from the smallest number, which was 1.689. That same rule that we talked about in 7.1 applies. Okay? Alright, next one. This one we're drawing the triangle ourselves. So, I'm going to go ahead and draw my angles. A, B, C. Again, I usually just use a capital C instead of the Greek letters. It doesn't really matter as long as you're able to differentiate. So A, little a goes across from big A. Okay, little b goes across from big B, and then alpha is my big A, which is 40 degrees. Alright, so this one I have two sides and an angle. Alright, so I can't go ahead and find my first angle because I don't have two angles, so I'm going to have to set up my first proportion. So sine of 40 over 3 equals sine of b over 2. Okay, so this time I don't know the angle, but I know the other side. So 2 sine of 40 equals 3 sine of b. Sine of b equals 2 sine of 40 over 3. Now remember, anytime you have sine of b, okay, you just find the inverse of that. So I'm just going to do sine inverse of 2 sine of 40 divided by 3. And so b equals 25.374 degrees. So a little bit different there. Now, here's a little bit of a catch here. We know whenever we do sine inverse, okay, that is only going to give us angles that are in right here. This goes back to our inverse sine. That inverse sine is restricted between negative pi over 2 and pi over 2, okay? But we know that there's actually angles that, for example, 2 sine of 40 divided by 3 is like 0.4, okay? We know that there's actually a sine angle that has 0.4 that's somewhere over here, okay, that there's other positive sine angles that exist over here, okay, that are never going to be taken into account, okay? So we need to take into account that our calculator will never give us something in quadrant number 2, okay? So this is how we're going to do that, okay? So how we do that is we're going to take 180 degrees, okay? And we're going to subtract it from what we got, which was 25.374 degrees, okay? Because that will give us the angle on the opposite side of our unit circle. So 25 degrees, that will give us the angle on the opposite side, okay? So 180 minus 25, so that will actually give us over here about 155. So that will give us the angle with the same sine value. Think about the same height. It will give us the value that has the same height, the same y value, the same sine, okay? So we get, let me actually do this, 180 minus 154.626 degrees. So this is the other possibility, okay? Because this angle has a sine value of 2 sine 40 divided by 3, which is about 0.4, but our calculator will not give us that value. It'll only give us that 25 degrees, okay? I know this is a little bit kind of a weird concept to think about. Now, here's what we have to do though. We have to say, can angle B equal 154.626 degrees? Well, let's see. Let's plug it in. If we plug in 154.626 degrees, and we add in angle A, plus 40 degrees, and we add it up, well, I know that's going to equal 194.626 degrees. Okay, well, we have a problem there, okay, because I know angles can only equal 180 degrees, okay? So therefore, I don't even have to worry about this other possibility, okay? Now we're going to get to one in a minute where I do have to worry about this other possibility, okay? But for now, because this guy right here, when I plugged it back into my triangle, this plus this was bigger than 180. I can't have a triangle bigger than 180, okay? Because when I plugged it back into my triangle, it was bigger than 180. I don't have to worry about the other case, all right? So I have my only possibility is 25.374 degrees. Now remember, we only had to worry about that because I did a sine inverse, and all the other ones I did so far, it was just solving for a side. This one I solved for an angle, okay? All right, so let's go ahead now, let's continue. Since we only have one possibility, it's just going to be like normal, and we'll go ahead and we'll solve for angle C now. So 180 minus 40 minus 25.374 gives me 114.626 degrees is angle C. Alright, and then the last thing I have to do, I still haven't found this side over here. Okay, so I still need to go about doing that. Okay, and I'm going to do that using the same law of sines. Okay, so I'm going to go ahead and set that up. So that's going to be sine of 114.626, and remember when you type that in your calculator, use that exact value that you had, over C equals sine of 40 over 3. So you're again just repeating that process. So I'm going to cross multiply here. 3 times sine of 114.626 equals C times sine of 40. So C equals 3 times sine of 114.626 divided by sine of 40. And again, I would do all the algebra on your paper before you try to type that in your calculator, just so you make sure that you're not rounding too early. And you end up getting C equals 4.243. Okay. Alright, we have 2 more left. Alright, so let's go ahead and draw out this triangle. Alright, so I have A, which is 6, B, which is 8, and A, which is 35 degrees. Alright, so I'm going to set this up as sine of 35 over 6. It's going to start looking very similar to the last one we did. Equals sine of B over 8. So you'll notice that we're solving for an angle here. So anytime we're solving for an angle, we're going to have to check for 2 of our cases. So when I cross multiply, I get 8 sine of 35 equals 6 sine of B. Divide both sides by 6. Sine of B equals 8 sine of 35 divided by 6. And we're going to take the inverse of that. So inverse of 8 sine of 35 divided by 6. And you should get for that B equals 49.886 degrees. Okay. Now remember, so 49 degrees is about a little over half. Okay. So that is where the sine value equals 8 sine of 35 divided by 6. Let me just type that in my calculator and get that as a number. So that is where the sine equals 0.76 approximately. Okay. But I know that my calculator will only give me values on the right side because that is your sine inverse restrictions. Okay. But I need to take into account that there's another place that sine equals 0.76 and it's right over here. Okay, that's where sine equals 0.76, and in order to find that value, you do 180 minus 49.886, and you will get 130.114. So this angle right here is 130.114 degrees. Okay, so in both of these angles right here, my sine is 8 sine 35 divided by 6. Now let's see if this angle even works in my triangle. 130.114 plus 35. It equals 165.114. Now since that's less than 180, both of these cases are going to work. So I need to take into account both of these triangles. And this is where you say, shoot, I have to do more work. Okay? So what I usually end up doing is I make a chart. Okay? And what I do is I put, so there's going to be 2 possible triangles. So I need to find angle B, I need to find angle C, and I need to find side C. Okay? So my triangle 1, and triangle 2. Okay, and I kind of just fill in the chart that way. So my first triangle, angle B was equal to 49.886 degrees. My other possibility was angle B was equal to 130.114 degrees. Okay, so those are your 2 possibilities for angle B. Now, depending on what angle B is, that will change the outcome of angle C. So let's find angle C for my first triangle. So angle C for my first triangle is going to be 180 minus 35 minus 49.886. And that will be 95.114 degrees. Okay, now obviously it will be different if angle B is 130 degrees. So that's 180 minus 35 minus 130.114 degrees. So let's find that guy. So my other possibility is 14.886 degrees. Okay? And lastly, we need to find side C, and that will vary depending on what my angle C is. Okay? So what we're going to do is we're going to set this up. So we have the same ratio, sine of 35 over 6 equals, and we're just going to plug in sine of 95.114 over C, and then we're going to use the other one, sine of 14.886 over C, because those are my two possibilities. Okay? So when you end up cross multiplying and doing all of that fun stuff, you're going to get 6 sine of 95.114 divided by sine of 35. 6 sine of 14.886 divided by sine of 35. Okay, and for the first row, when it's 95.114, C should be 10.419. And for the second row, it should be 2.687. And this should kind of make sense just by looking at it. Like when C, my angle is smaller, my side's going to be smaller. My side across from it's going to be smaller. Okay? Alright, last one. Alright, and like I said, we're not going to do a ton of application with it, but I do want you to be able to solve these triangles, so we're going to stop right after this example. And a lot of those also involve the bearing that we're not going to worry about for now, just due to sake of time. Alright, so A, B, and C. So A is 2, C is 1, and that's just big C, which is 50 degrees. Alright, so we're going to set it up the same way. So sine of 50 divided by 1 equals sine of A divided by 2. Because remember, it's got to be the side across from it. Cross multiply, so 2 sine of 50 equals 1 sine of A. Alright, so I would just be dividing by 1. So sine of A equals 2 sine of 50. Now when you do 2 sine of 50 in your calculator, you get sine of A equals 1.53. Okay, now when you try to take the inverse of that, it doesn't work because we know that sine has to fall between -1 and +1. So we can say two possible things for this. We can say, 1, this triangle does not exist. Also, you could be asked a question about how many possible triangles exist. So for the ones like all of these were all one possible triangle, right? There were only one answer, one set of answers, etc. This first example we did here, there were two possible triangles, right? 1, 2, okay? This one, you could say there are 0 possible triangles. And again, the reason being, when you try to take the sine inverse of 1.53, you could try it on your calculator, you could just remember, sine does not go bigger than 1. So that is not going to happen. Okay, so therefore that does not exist. Okay, so that is, I know there's some practice on your Delta Math. I would be sure to do that because a lot of this will just take practice in working with those numbers. Okay, and that's all.